Okay, Twin Turbo Tuesday then. What hopefully will be the final video. Say hopefully because no project is ever final, obviously. But we've got the fuel maps where we want them to be on £7 a boost, and there is potential for a bit more. I'm not sure whether we even need to go there. It's doing everything I need it to do. We're going to ask the question that everyone's been asking: how much power? It doesn't ultimately actually make any difference to me. The car does what I needed it and originally wanted it to do with this twin turbo conversion now, which is tow with a trailer really nicely with minimal effort. You know, not having to kick down at the second at 50 mile an hour if you see a hill and that sort of thing. So we are using the same dyno as we did originally for the 244 power figure, and we will show you the film of that and then go into a bit more technical. Okay, so good results there really. We went from 255 foot-pound torque on this engine before the turbos to 344, and that's what we're experiencing on the road, all that mid-range power. And horsepower, we went from 240 to just shy of 300, certainly pub torque 300. I'm sure lots of people will say, oh, you know, it could make more horsepower. Absolutely it could. If we change the intake setup, this is our limiting factor on airflow, for sure, without a doubt, and potentially some headwork. But I've never really been shooting for the horsepower number. It's always been about the drivability. I will just counter that statement slightly, because I did get stuck on the horsepower figure for a little while, didn't I, Steve?
You did.
So I did throw around a figure a couple of times on the internet. One of the dyno sessions we had as part of the tuning sessions on this, the dyno was unfortunately incorrectly calibrated to engine RPM, and we ended up with a BHP figure of just shy of 380. So for a little while I was a little bit giddy, thinking we maybe had much higher horsepower figures. Not that it's really relevant unless you're driving at 5,000 RPM all the time, which obviously in this style of vehicle you're not going to. That brings me on to something else a few people have mentioned to me, which is, have you upgraded your brakes? I'm still restricted by all the signs, red circles, black numbers inside of them telling me how fast I can go, and I can still only tow the same weight. So no, all the brakes are, well, they were all refreshed 2.5–3 years ago. The brakes on this are incredibly good for a 22-year-old vehicle because of everything being refreshed. But no, I haven't upgraded the brakes because I still drive at the same speed. I just get there slightly faster, and like I say, can still tow the same weight, and I'm certainly not going to be taking it to a racetrack, so brake fade and things aren't going to be an issue. Probably best we go out on the road now and actually film some bits out there.
Yeah, I think that's what we want.
We'll try and do that between rain showers.
Yes, of which there are a few today.
Yeah. Right, out on the road then, which, let's face it, is the bit that actually really matters. Big difference in the way the car drives. Even with small throttle input, we're picking up and accelerating up to, and remembering this bit is now 30 because it never used to be, really nicely. In fact, I've got an idea. You've not driven this, have you?
I have not.
You've only experienced it from the passenger seat.
Yes, correct.
But you can't tell where the throttle pedal is from there.
It's pretty difficult, yeah.
Okay, let's switch seats. Okay, Steve's driving the car.
I am. Hello.
Whenever you're ready.
Yeah, it picks up all right. Yeah, I mean that was barely any throttle at all, probably 20-25%, and yeah, the torque's there.
It certainly goes, doesn't it? And like you say, that's not something rolling road power figures kind of put over, because there you're just looking at peaks. Obviously you've got the dyno graph of the RPM range run, but you're not looking at what you drive on. You never drive, or very rarely do you drive on full throttle.
Not with today's fuel prices.
This is on LPG. You've not noticed it's.
Wow.
This still costs the same. In fact, I'm glad you brought the point up. Is everybody's going to go, oh, it consumes loads of fuel? Well, before twin turboing this, I used to do locally about 180 to 200 miles to a tank of LPG, and I still do.
Can't ask for a lot more than that, can you?
No, and the theory there really is I get to my cruise speeds quicker with less accelerator input, although obviously more power, and then I'm cruising. And on cruise with turbos, you're still on intake vacuum, your engine is still the same displacement, it's still the same camshaft fitted, you know, no hardware on the engine has changed. So realistically, on cruise, the fuel efficiency hasn't changed. If anything, it might have got marginally better on petrol because of those 12-point injectors I fitted. I haven't done an MPG test on petrol yet. I have not brimmed the tank on Shell V-Power. Yes, the over £2 a litre has scared me off from doing that. I would like to, and maybe I'll bite the bullet and fill it with Shell V-Power and publish the figures at some point. But I still very much think it will be in the region of 20 to 22 to the gallon on petrol on a run. I have no reason to doubt that due to the LPG consumption at the moment. Oh, you see national speed limit signs.
So do I.
I slipped into Norfolk then.
That'll happen when you're in Norfolk.
Yeah,
And
in
from
a
Norfolk.
Land Rover.
In a Land Rover. Right then, let's give it some. Whoa! Yeah, that's got some go.
It feels different from the driver's seat because you know where the pedal is, don't you?
Yeah, yeah. So it's.
I must admit, this is the first time I've experienced it from the passenger seat, and I'm still impressed from this side, because I'm not sure when you're going to push the accelerator pedal. Yeah. Cool. Well, hopefully.
Yes. Put a smile on my face.
Yeah. Well, it's my car. You're not taking it home. Do we admit to people what you drive?
Can if you like. I'm not ashamed.
It's turboed.
It is turboed.
It's still a
I
Land
think I
Rover.
actually mentioned it in a previous video.
Did you? Yeah.
Maybe.
Okay. Yeah. So Steve has had a couple of V8 P38s, but currently you're in a
Diesel. I'll say it for
I
you,
can't
so you
say
don't
it.
have to
I can't say
dirty
it.
your mouth.
Still a nice vehicle. Big off-road tyres. You're enjoying off-road, aren't you?
Yeah, I've been doing some off-roading.
Okay, so we're heading out for a drive with Dave in the car. Many of you might know Dave or recognise Dave. You break a lot of these, don't you?
Yeah, pretty
You
much.
send them to the grave to keep others going.
We certainly do.
So you own P38, 4.6, if I remember correctly, 285 cam, stage 3 heads
Yep.
on the Thor intake.
That's correct, yeah.
And you have also just delivered to us a load of core material, engines. Thank you very much.
No problem.
You have your Discovery 2.
Yes, we do, yeah. That's the good old reliable tow vehicle
With a 4.6 in it.
with a 4.6.
So you're very much used to these with 4.6s in.
Yes.
Your Range Rover you're going through a bit of a rebuild on at the moment, aren't you?
Yeah, doing a full restoration, yeah. Yeah, that's now in paint.
Excellent. I've seen pictures of it and I've seen it in person, and I must say you're doing a brilliant job.
Thank you very much.
Its powder coating axles really is taking it to the nth degree.
Yes. Yeah.
Right, so we'll head out, we'll have a play, and then I reckon we'll throw you behind the wheel as well.
Yes, mate. Can't wait. Definitely feel the difference. Just a gentle.
Is it? You've only got to be,
press.
what, 30% on the pedal?
Yeah, definitely. Yeah.
Let the modern Range Rover get out of the way.
Proper one coming past.
Yeah. question earlier of LPG or petrol, you're on LPG.
This is on gas, is it?
Yeah.
It's incredible, isn't it? Just there, you're just feathering the throttle, and it's just pulling.
It's as if you're full pedal down, isn't it?
Yeah, in a normal Range Rover, for it to pull like that, it would be foot to
foot to
down.
the floor,
Yeah.
up the revs.
Yeah, 100%. That's incredible. I mean, literally, you push that throttle an inch, and it just, the torque is amazing.
There's no lag.
No, I mean, look at that. I mean, that's hardly on the throttle, and it's just there, isn't it?
Yep. If you take a right at this crossroads.
I think it should have been built like this from the factory. It's been a lot more fun. I've had a little drive of it myself, and I can honestly say I've never drove a P38 like it. I've driven hundreds of P38s over sort of 12 years of working on them and repairing them and everything else, and yeah, I can honestly say that the torque is amazing. You literally feather the throttle and it's there. It's on demand when you want it. I mean, to get that kind of torque and that kind of pull out of a normal P38, which, like I say, I've driven hundreds of them over the years, and that would pretty much be foot flat to the floor to get it to go like that. So I'm seriously impressed, and I think I'll
give you the 20 quid later, mate. Right?
I can see the East Coast Range Rover's P38 company car having a twin turbo conversion.
Sounds good to me. You've owned a few V8s, so has it just been the series, or?
No, this is my second V8.
Okay.
Both have been 3.5s. The only other one was in a 110 I put together with my son on LPG, which
Okay, yep.
Chris himself helped me out with on the LPG system at the time.
Yep.
In fact,
cool.
the engine came from Chris as well. That was the one that came out of the Gloucester car.
Oh, right, yeah. The original.
Yes. Yeah, the one you took out before you put the
Monster in
5.2 in
5.2 or 5.3 or something, yeah, I forget now, yeah.
But this one I'm running now, I've been running for over 30 years.
Same engine?
Same engine. It's a 1984 out of a Range Rover of that era, on those twin Strombergs that Chris always hated. So, smooth lane, gentle bit of power. Oh, that feels nice. There's loads more as well. And that's 70 miles an hour, just like that.
Yeah. And you,
No drama.
no. Now if you press that button to the right of the steering wheel, the LPG switch, just press it in once, it should then switch to LPG, and you'll feel, we'll take a left here and head down Reefham Road. You'll feel I can't tell a difference.
So we're now on LPG.
Yep.
Get on the straight, and I'll just feed on some more power. Yeah, it's just as good, isn't it? That's 50, which is more than enough for this brow coming up. That's nice, Ian.
So if you're now at 50, you're in torque converter lockup. If you just lean on it just a little, you'll feel instantly.
Yeah.
Okay, a bit of a technical specification area in terms of what's what. So the engine itself is a 4.6 with standard heads, or RPI Engineering, our standard of heads, so bullet valve guides, 3-angle valve seats, Piper 270 camshaft. That is as it was on the pre-dyno run that we did before the turbos went on. It was never built when I built it a few years back after hydraulicking in water and bending a conrod. I never built it with this in mind. Compression ratio, I did CC the heads though, so I've now worked out compression ratio is somewhere between 9.4 and 9.5. That's just where it is, and it's all standard pistons, etc. So moving on from the core engine, as I've previously mentioned, GT25 60R turbos. So they are plumbed in a fashion where the driver's side bank is feeding, comes forwards under the engine, or under the front of the engine, and feeds the front turbo. The rear turbo is fed off of the passenger side. Outlets of those are Y-pieced in together here and runs through the charge cooler before we come up through into the throttle housing. The charge cooler has got its own radiator at the front here. It's its own cooling system. There is a Bosch pump mounted under here, and then a header tank, so when the engine's running this is circulating fluid round and keeping this cool. The highest inlet temps I've seen after a long run on the road and you know, keeping it in boost for some time, about 38 degrees inlet temps, which are, you know, fine. So the cooler you can get them, the better, but they're certainly not near any limits that we need to be worried about. There's a recirculating valve here, so when we let our foot off the throttle and pressure builds in the intake pipe because the turbos are still spinning, it actually recirculates back round to the inlet of the turbos, which should stop the turbos from stalling suddenly and causing premature spindle wear or bearing wear. They are fed with oil from outlet on the side of the timing cover that I put in. Comes up through an AN6 line, Y-pieces off into two AN4s, and then the oil return lines are both AN10s that go into the side of the sump separately. Water is fed on the heater matrix out, Y-pieced off to each turbo, and then Y-pieces back together again and goes off to my vaporizer. I'm still running on LPG. Runs absolutely lovely on LPG. I think the only time where the LPG system isn't quite man enough for all the power produced is if you're up in the higher rev range, sort of 4.5, 5,000 RPM, and then you suddenly demand for more and it goes into kick down, and you know, you're suddenly spooling the turbos up. You can't convert liquid to vapor LPG that quickly. I could add another vaporizer in to just deal with that, but it's not an issue, so it's not really a problem that needs fixing. For everyday to even spirited driving, LPG is no issue at all. Converted on the inlet side of the turbos to a larger airflow meter. So we've got a Bosch airflow meter off a 4.4 BMW, which allows more air to pass through it, which actually means we get a larger scale. So although we could flow the same amount of air through a 4.6 airflow meter, it just moves faster because it's smaller in diameter. It wouldn't give the same scale when it comes to talking to the ECU and tuning the engine. Having a larger scale means we can get a better calibration of air-fuel mixtures through our progressive throttle and progressive airflow rate. So that's why we've converted over to that. Fuel setup, I have had to change. On Thor engines like this, the regulation of fuel pressure is done in the tank and it's not manifold referenced, so it's a steady rate. I've put a larger fuel pump in, a larger Walbro fuel pump, and we had some issues there in the early days of this and the mid days actually as well. So I've ended up converting to a bulkhead mounted regulator, still not manifold referenced, but we're now controlling the pressure up at the engine end, so we're not now seeing fuel pressure variation where we were previously. So that's hard lined front to rear with AN fittings as well. Still retained under here, air conditioning, it's all standard. Haven't had to change anything there at all still functional. We do get a little bit of sweat up on this pipe here that's passing at the rear turbo, but that's one of the things, you know, if you cram all this in here, there's going to be little compromises, but the air conditioning still works. Cruise control still on here, running no problem at all. Obviously air suspension is not retained, primarily because I didn't have it in the first place. This was on coils when I bought it, and I do plan to put it back on air because I'd like to retain some of that comfort of ride that it offers. However, I've always had the intention when I do that the pump and the valve block can be relocated in the spare wheel well. It's only wires that have to be lengthened and pipes, so that's an easy thing. I'm confident that's achievable without any issue at all. I think that finishes that bit.
You tell me. You built it.
Yeah, you keep remembering extra things. There's a lot going on. Okay, so to answer many of the questions that have been asked through this project, this is going to be a more technical section. I may run on a bit, many of you know I do anyway.
That's unlike you.
Yeah, exactly. First of all, I will just touch on something I previously mentioned about an incorrectly calibrated dyno. By that I don't mean torque figures, I mean horsepower figures. Horsepower is just a calculation of torque against time or engine RPM. So all dyno graphs that are on the same scale, foot-pound to BHP, if the scales are the same, they will all cross at just over 5,200 RPM. I think it's 5,252 RPM. If they don't and the scales are the same, then something's calibrated wrong. Now, quite often, we aren't on the same scale, and that was certainly the case on this one that gave me a misleading figure. The scales weren't the same. Unfortunately, because of torque converter slip, when they were teaching at 3,000 RPM, the torque converter was still slipping because the gearbox wasn't up to temperature, and for that reason we ended up with a peak power figure at 6,300 RPM. And later on, when I realised this RPM range, I was talking to Mark, who's doing the dyno tune and that sort of thing. We realised that the rev limit is obviously lower in the ECU, about 5, 8, 6, something like that, and yeah, we realised those BHP figures were incorrect. So back down to more realistic figures for what we've done here and what we're achieving. So I'm going to go over what we've done originally, because lots of people are watching these videos and have not watched the earlier videos. So we're twin turbo, twin Garrett GT 2560Rs. So they're rollable bearing turbos. Spec'd nice and small so that they spool up nice and quick and create that bottom end to mid-range torque that I always intended to do this conversion for. Lots of people said, oh, supercharger, that's the easier route to go. Certainly is. You don't have to build any exhaust manifolds. You do need to obviously run a belt drive somewhere though. You know, superchargers are used for that bottom end grunt. Well, as already proven, turbos can do it too. And I wanted to do something a bit different. I wanted to play with turbos as well. Yeah, it's worked. It's done what I've wanted it to do. I'm not going to progress further down the line. I'm not going to change the intake manifold and shoot for those bigger horsepower numbers. I've got another build in mind where I'm going to be doing a bit more, etc. Potentially in the next year or two, which will be far more fun, a better car that's more suited to power, better power to weight ratio, etc., and that sort of thing. Okay, ECUs, there was a fork in the road where I had to make the choice of sticking with the standard ECU or going down the standalone route. I've stuck down the Bosch standard ECU route and been working closely with Mark at Tornado on the mapping, etc., and calibration of this. It has meant a lot of development on his part, which I'm hugely grateful for, because we've ended up having to change fuel tables and comparison tables that he's never had to do before because of the amount of airflow we have in relationship to engine RPM and throttle position sensor. Had I gone the standalone route, it would have had lots of positives in terms of more scope for tunability, you know, integrated boost control, running a map sensor rather than a MAF, etc., etc. However, the cons, for me, I didn't want to move away from the P38 dashboard or the BCM, integration to the BCM and the auto gearbox. They could have been overcome, and maybe even the standalone ECU could have communicated with them, but unfortunately no one I was talking to of multiple standalone engine management producers wanted to actually get involved in helping produce that. So we went down the Bosch route, and you know, again, it's done what we've needed it to do. There's just been some hurdles, but there would have been hurdles down the other path as well. Okay, lots of people as well as asking the how much power does it make, which we've obviously now answered, have asked how much boost we're running. We're running between about £6 and £7 a boost, purely because I never planned to run any more for two main reasons. One, this is a standard build engine. When I rebuilt this engine a few years back after I hydraulicked it off-roading and bent a conrod, I never, at that point when I built it, intended to go forced induction. It's just something I developed onto. And and standard pistons are known to start going soft and kind of melt at higher power levels, around the 400 foot-pound torque mark, etc. I'm sure there's people out there saying they're running more on them. Marvellous. I want this to be reliable, and I'm not saying that yours potentially isn't at that level, but from speaking to Mark, he's known them to melt when you start going over those figures, and we knew this kind of power level would be where that would give the power we were after. Also, waiting for the tractor to go past. Also, the automatic gearbox, speaking to Ashcroft, we knew that similar power level, or that ceiling we knew we didn't want to kind of get to, would be where clutch packs would start slipping on the gearbox unless we started looking at how to increase hydraulic pressure in the gearbox, etc. Again, I didn't want to go down that route. Yes, it would be nice to convert this to manual, and for sure we'd get better dyno figures because we could run foot flat to the floor from right down the bottom end of the rev range to bring it on boost early, whereas at the moment we can't do that because it simply kicks down and you don't get a dyno run. So we're running 6 to 7 pound of boost, and that's why. Okay, so that is the end of the Twin Turbo Tuesday videos. This video probably won't be going up on a Tuesday, it'll be a different day, but that doesn't really matter. So yeah, huge gain, 90 foot-pound of torque. Definitely not grumbling at that at all. 60 horsepower, very nice. More could be achieved, but this car doesn't need it. It's the torque we're driving on, as already demonstrated. Thank you for watching this video series, and certainly if you've made it to the end of this video, thank you for listening to me running on and on about stuff. And things. So obviously lots more RPI videos that we're doing, project videos, etc. And no doubt I will hit another project at some point and share it with you. Thanks for watching, guys.